Have you ever looked up at the night sky on a clear dark night far away from the city lights and wondered, truly wondered, if we're alone in this vast, awe-inspiring cosmic ocean? Is there anyone else out there looking back at us, pondering the same question? That question, that fundamental yearning to understand our place in the universe, has echoed through human history, resonating in the hearts and minds of thinkers and dreamers for millennia. It's a question that has inspired myths, stories passed down through generations, attempting to explain the mysteries of the cosmos and our connection to it. It has fueled scientific inquiry, driving us to develop tools and methods to probe the depths of space and unravel the secrets of the stars. And it has propelled exploration, pushing us to venture beyond our planet and seek answers among the celestial bodies. For most of our existence, since we first looked up and wondered, we could only speculate, relying on philosophy and imagination to fill the gaps in our knowledge. We could only dream of what might be. The stars were mysterious, distant points of light, their true nature hidden from our view. And our solar system, with its single star and familiar planets, seemed unique, a potentially rare oasis in the vast emptiness. But in the last few decades, everything changed. Thanks to incredible advancements in technology and our understanding of the universe, we built powerful telescopes, both on the ground and in space, capable of peering across vast distances and capturing faint signals from the depths of the cosmos. And with these new eyes, we began to peer deep into the galaxy, beyond our own solar system, and uncover secrets that were previously unimaginable. Now, we know our solar system isn't unique, it's just one of countless planetary systems scattered throughout the Milky Way. Planets are everywhere, orbiting stars of all sizes and types, in a dazzling array of configurations. Every star you see in the night sky, each tiny point of light, likely has its own family of planets, a retinue of worlds circling it in the darkness. The question, "Are we alone?" is no longer just philosophy, a matter of speculation and conjecture. It's a scientific investigation, a quest driven by data, observation, and rigorous analysis. We are the first generation in human history to know, with a high degree of certainty, that the universe is filled with countless worlds, each with its own unique potential. The cosmos is richer, more diverse, and more complex than we ever imagined, a tapestry woven with stars, planets, galaxies, and nebulae beyond our wildest dreams. And the search for life beyond Earth, the quest to find our cosmic neighbors, has truly begun, fueled by unprecedented knowledge and driven by an insatiable curiosity. As we gaze out into the vast expanse of the cosmos, a question naturally arises. What are these new worlds that we're discovering beyond our solar system? What secrets do they hold, and how do they compare to our own planetary neighborhood? We call them exoplanets, a term that signifies their existence outside of our solar system. These are planets orbiting stars beyond our solar system, distant suns, each potentially nurturing their own families of worlds. They represent a fundamental shift in our understanding of the universe and our place within it. Until the 1990s, our knowledge of planets was limited to our immediate cosmic vicinity. We only knew of the planets in our own solar system, the familiar worlds that have been studied for centuries. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune were the extent of our planetary census. That changed dramatically with the groundbreaking discovery of 51 Pegasi b in 1995. This was the first exoplanet found orbiting a sun-like star, a revelation that opened up an entirely new field of astronomical research. It proved that planets existed around other stars, challenging our long-held assumptions. Since then, fueled by advancements in telescope technology and innovative detection methods, astronomers have confirmed the existence of over 5,000 exoplanets. And the number keeps growing, with new discoveries being announced regularly. Each new exoplanet adds another piece to the puzzle, helping us to better understand the diversity and prevalence of planetary systems throughout the galaxy. These discoveries have fundamentally redrawn our map of the galaxy, revealing a universe far more populated with planets than we ever imagined. Scientists now estimate that there are more planets than stars in the Milky Way, a staggering realization that underscores the sheer abundance of these celestial bodies. This translates to trillions of worlds, each with its own unique characteristics and potential. Earth, our home, is just one grain of sand on a vast cosmic beach, a single planet among countless others scattered across the galaxy. Each star could host its own unique system of planets, a diverse collection of worlds orbiting in different configurations and at varying distances. These exoplanets possess their own unique chemistries, with atmospheres composed of different gases and elements, leading to a stunning array of colors and compositions. And perhaps most tantalizingly, some of these worlds may harbor their own biologies, life forms adapted to environments vastly different from our own. The universe is teeming with planetary real estate, a vast and unexplored frontier ripe for discovery. Our next challenge, the next great leap in our understanding of the cosmos, is to understand what these worlds are really like, to unravel their mysteries and to determine whether or not we are alone in the universe. Finding exoplanets is a feat of scientific detective work. Planets are tiny and faint compared to their stars, making them nearly impossible to see directly. So astronomers use indirect methods, searching for subtle effects planets have on their stars. The two most successful techniques are the transit method and the radial velocity method. The transit method reveals a planet's size and orbit. The radial velocity method tells us its mass. When combined, we can estimate a planet's density and composition. Direct imaging is rare, but with advanced telescopes and coronagraphs, we've begun to capture actual images of a few giant exoplanets. Each new detection brings us closer to seeing worlds like our own. The hunt for exoplanets is just getting started. The transit method is the most prolific way to find exoplanets. If a planet passes in front of its star from our viewpoint, it causes a tiny dip in the star's brightness, a transit. Space telescopes like Kepler and TESS monitor thousands of stars, searching for these rhythmic winks. The amount of light blocked tells us the planet's size. The timing reveals its orbit. This method has discovered more than 3/4 of all known exoplanets. It's shown us that planetary systems are common and diverse, but it only works for systems aligned just right. Many planets remain hidden. Still, the sheer number of discoveries is staggering. Each transit is a clue, revealing the hidden architecture of distant solar systems. The universe is full of surprises. The radial velocity or wobble method is another cornerstone of exoplanet discovery. Planets and stars orbit a common center of mass, causing the star to wobble slightly. We detect this wobble by measuring tiny shifts in the star's light spectrum. Blue shift as it moves toward us, red shift as it moves away. This Doppler effect reveals the presence of unseen planets. The size of the wobble tells us the planet's mass, the timing gives us its orbit. This method excels at finding massive planets close to their stars. It's harder to spot small, Earth-like planets, but combining this data with transits lets us calculate density. That's how we distinguish between gas giants and rocky worlds. Together, these methods are revolutionizing our understanding of planetary systems. The exoplanets we've found are astonishingly diverse, many unlike anything in our solar system. Hot Jupiters, for example, are giant gas planets orbiting scorchingly close to their stars, with years that last just days. Their existence forced us to rethink how planets form and migrate. Then there are super-Earths, planets larger than Earth but smaller than Neptune, some rocky, some possibly covered in oceans or lava. We've even found rogue planets, drifting alone through space without a star. Some worlds orbit two stars, like Tatooine from Star Wars. Others circle dead stars called pulsars. Each discovery challenges our theories and expands our imagination. The universe is a cosmic zoo of strange and wonderful worlds. Every new planet adds to our gallery of the unexpected. The possibilities are endless. With trillions of planets, could any support life? Scientists look for planets in the habitable zone, the region around a star where liquid water could exist. The habitable zone's location depends on the star's type and brightness. A planet also needs to be the right size and have a suitable atmosphere. We've found promising candidates like Proxima b and Kepler, 452b, both rocky worlds in their stars' habitable zones. The TRAPPIST-1 system is especially exciting, with 7 Earth-sized planets, 3 in the habitable zone. These systems are natural laboratories for studying potential life. Finding habitable planets is just the first step. The next challenge? Discovering if they're truly alive. The quest to find life beyond Earth is one of humanity's most ambitious endeavors, and to search for life, we need to study exoplanet atmospheres. These gaseous envelopes surrounding distant worlds hold crucial clues about their potential habitability and the presence of life itself. Understanding their composition is paramount. On Earth, the abundance of oxygen in our air is a direct result of life, specifically, photosynthesis carried out by plants and microorganisms over billions of years. Oxygen is so abundant because of life. So, could we find similar signs elsewhere? Could the presence of certain gases in an exoplanet's atmosphere point to biological activity on its surface? This is the tantalizing question driving much of exoplanet research. Using a powerful technique called transit spectroscopy, we can begin to unravel the mysteries of these distant atmospheres. Transit spectroscopy allows astronomers to analyze starlight as it passes through a planet's atmosphere. This is a crucial moment, as the starlight interacts with the atmospheric gases. This occurs during a transit, when the exoplanet passes directly between its star and our telescopes. As starlight filters through the atmosphere, different gases absorb specific wavelengths of light. This absorption leaves a unique chemical fingerprint in the light, a pattern that reveals the atmosphere's composition. Powerful telescopes like the James Webb Space Telescope, with their advanced infrared capabilities, can detect the presence of water vapor, a key ingredient for life as we know it. It can also detect methane, carbon dioxide, and even oxygen, though oxygen detection requires careful analysis to rule out non-biological sources. Finding these gases in the right mix, in proportions that defy expectations based on non-biological processes, could be a powerful sign of life, a potential biosignature indicating the presence of living organisms. But it's a painstaking process, requiring meticulous observation, data processing, and analysis. The signals are incredibly faint, often buried in noise, and false positives caused by non-biological phenomena must be carefully ruled out through rigorous scientific investigation. Yet for the first time in human history, we have the technology, the tools, and the expertise to sniff the air of distant worlds, to probe their atmospheres for signs of life. We're already studying planets in systems like TRAPPIST-1, a compact system of 7 Earth-sized planets orbiting a red dwarf star, searching for biosignatures and clues about their potential habitability. The next few years, with the continued operation of JWST and the development of even more advanced telescopes, could bring the most profound discovery in human history, evidence that we are not alone in the universe. The study of exoplanets is more than science, it's a quest to understand our place in the universe. Each new world teaches us about planet formation and the uniqueness of our own solar system. Searching for habitable worlds forces us to appreciate Earth's rare and fragile conditions. This cosmic perspective inspires us to protect our home planet. Discovering life elsewhere would transform our view of the universe and ourselves. It would show that life is a natural outcome of cosmic processes, not a fluke. We are part of a much larger story unfolding across billions of worlds. The search continues, and the next chapter is just beginning.